Okay, so let's unpack this a bit. Have you ever been in like a busy group chat and you're trying to figure out exactly the right moment to jump in?
Oh, yeah. All the time.
It's tricky, right?
Right.
Even for us humans. You
Yeah.
don't want to interrupt, but you also don't want to, miss your chance.
Definitely.
Well, imagine teaching an AI to do that,
Hmm.
to figure out not just what to say, but when to say it in a really fast-paced, multi-person conversation.
Uh-huh.
That's the really fascinating challenge that a new paper tackles. It's called Time to Talk X.
And what's so interesting here, I think, is how this research, it's from Eckhaus, Yuri Berger, and Gabriel Stanovsky, researchers at the Hebrew University of Jerusalem and the University of Melbourne. It really bridges a critical gap.
A gap in how LLMs interact.
Exactly, how large language models interact in these really dynamic, fluid settings. So our mission today is to really dig into this paper. We'll look at their adaptive LLM agent, how it handles this tricky social timing thing in group chat, specifically in a game setting, and, what it all means.
Sounds good. We should probably start with the basics. Most chatbots we use, they're pretty straightforward, right? It's like taking turns.
Yeah, that's what they call synchronous communication. It's that clean back and forth. You ask, it answers, it waits. Very orderly.
But real conversations, especially in groups, they're hardly ever that neat.
Precisely. And that's the core problem they're tackling. Asynchrony. If you think about it, so many real-world interactions are inherently asynchronous.
But group chats, team meetings.
Exactly. There aren't any predefined turns. People might type at the same time, pause, wait for an opening. So for an LLM, the big question isn't just what to say, which is already hard enough, but when.
Right. When do you jump in? When do you hold back?
And according to the paper, they believe this is actually the first work to really tackle group asynchronous communication for LLMs head on. It's all about that crucial decision. Interject now. Wait. Say nothing.
That dynamic timing. Yeah, that seems incredibly complex to model for an AI.
It really is.
So how did they actually do it? How did they design an agent that can handle this conversational dance?
Well, this is where it gets pretty clever. They built this agent called Time to Talk X, and it basically has two core modules working together.
Two modules. Okay.
Yeah, think of it like a two-step process using LLMs. First, there's the scheduler. Its job is purely to decide whether to post a message to the chat at a given moment. It's like the gatekeeper.
Okay, so it's constantly asking, is now good time?
Exactly. It assesses the whole situation.
Yeah.
And if the scheduler says, yes, go ahead, it then triggers the second module, the generator.
And that's the part that writes the message.
That's right. The generator composes the actual message content. And the key thing is both of these modules use LLMs, and they both get fed the same rich context.
What kind of context?
Everything, really. The overall chat setting, the current time, who's participating, the entire message history, timestamps included, everything they need to sort of read the room.
That makes a lot of sense. You need all that info to make a good timing decision. But wait, how does it stop the AI from just talking constantly? Or the opposite, being too quiet? Humans adjust,
Good point. And they thought of that. It's a really neat feature they call dynamic scheduler prompting.
Dynamic prompting.
Yeah. The instructions, the prompt given to the scheduler LLM actually changes based on how much the agent has been talking recently compared to everyone else.
Ah, okay. So it adapts.
Exactly. If the agent's been quiet, the prompt might urge the LLM to be more talkative, give it a little nudge.
And if it's been talking too much?
Then the instruction is amended to signal it should speak only if necessary, basically telling it to maybe take a step back, act more like a listener.
Is there a specific rule for that?
Yeah, they mention a ratio. It's encouraged to speak more if its message rate is lower than 1 divided by n, where n is the number of active participants. But if it goes over that, it's prompted to be more reserved. It tries to keep things balanced.
That's clever. Really trying to mimic that social awareness.
Yeah.
And they added something else too, didn't they? About typing time.
Oh, yeah, another nice touch. To make the timing feel even more natural, more human, they built in a simulated typing delay.
So it doesn't just instantly pop out a message.
Right. After the generator creates a message, there's a pause, a delay, based on how long the message is, and an average human typing speed they used about 1 word per second. It adds to that realism.
And which LLM did they use for all this?
For both the scheduler and the generator, they used Llama 3.1-8B Instruct. So, a reasonably sized model, but clearly capable enough for this task.
Okay, so you've got this sophisticated agent designed to handle timing, adapt its talkativeness, even simulate typing. Now you need to test it. really put it through its paces.
Precisely. You need an environment where communication, timing, even suspicion are absolutely critical.
And what better place than Mafia?
Exactly. The classic social deduction game. It turned out to be a fantastic testbed for several reasons.
Why Mafia specifically?
Well, first, it's a game that can be played solely on textual interaction. Perfect for LLMs, right? No visuals or complex actions needed.
Makes sense.
Second, it inherently requires collaboration under uncertainty. You have to talk to figure things out, even if you can't trust everyone. Communication is key.
Okay.
But the most important reason, I think, is that the game centers around suspicion of other players. And here's the kicker. Both extreme strategies of constantly speaking or not speaking at all can be seen as suspicious.
So you can't just spam the chat, but you also can't just lurk silently.
Exactly. Which means communication timing becomes crucial for the player's success. If you speak at the wrong time, or too much or too little, you draw suspicion. So winning the game is actually a pretty good measure of how well you communicated, timing included.
Maybe just a quick refresher for anyone who hasn't played.
Sure. Basically, you have players secretly assigned roles. Some are Mafia, the bad guys, and the rest are innocent bystanders, the good guys. During the daytime, everyone talks. They discuss who they suspect is Mafia, accuse each other, defend themselves, and then they vote to eliminate someone.
High drama potential.
Oh, yeah. Then comes the nighttime. Only the Mafia players wake up and secretly choose one bystander to eliminate. Then a new day starts. This cycle repeats until either all the Mafia are eliminated or the Mafia outnumber the bystanders.
So it's all about deduction, bluffing, persuasion, and crucially, when you choose to speak up or stay quiet.
Spot on.
Okay, so Mafia is the perfect testing ground. Now, to actually run these tests and analyze them, they needed data. Lots of it.
Correct. And this led them to create something pretty unique, the LL-Mafia dataset.
LL-Mafia. I
Yeah.
like it.
Yeah. And it's not just recordings of humans playing Mafia. It's described as the first of its kind to integrate an LL agent with human players in Mafia games.
So the AI was actually playing with humans.
Yes. The dataset covers 21 games and 2,558 messages in total. And significantly, 211 of those messages were sent by the LLM agent playing alongside the humans.
Wow. How many people were involved?
They recruited 64 human participants, all fluent in English. They played about 2 games each on average.
And ethically, did the humans know they were playing with an AI?
Yes, that was important. Participants were told up front that one player was an AI, but crucially, they didn't know which player it was during the game. They also consented to their anonymized data being collected, and the whole process got ethical approval. They were careful about privacy.
Good. And the LLM agent itself, we know it's Llama 3.18b. Anything specific about how it was prompted to behave in the game?
Yeah, the generator prompt was specifically designed to encourage short, informal messages, using slang, making sure the messages were relevant to what was happening right then in the game, and trying to avoid just repeating the same phrases over and over. They wanted it to sound like a plausible player.
Okay. And after the game, they asked the humans. What?
2 main things. First, they asked them to try and guess which player was the AI. Then, regardless of their guess, they had to rate the AI player they were told about on scales for human similarity, timing appropriateness, and message relevance. Really valuable feedback.
All right, the moment of truth then. You got the agent, the game, the data. How did Time to Talk X actually do? Did it manage to blend in? Or did it stick out like a sore thumb?
Well, the results are pretty fascinating, especially when you look at the timing and the sheer amount of messages.
Did it talk too much?
Too little. Actually, it was remarkably close to the humans. The paper states it sends a similar amount of messages on average to a human player.
Really? What were the numbers?
Humans averaged about 4.54 messages per daytime phase, with some variation, of course. The LLM agent averaged 4.28 messages. Very close.
Wow.
And it wasn't just the quantity, its timing behavior also closely mirrors human behavior. Things like the time gap since the last message from anyone, or the time between its own messages. It matched human patterns quite well, although maybe with slightly less variability.
So it wasn't rigidly predictable, but maybe a bit smoother than humans?
Something like that. And it showed adaptivity, too. The analysis found that as human players are voted out, remaining players, including the agent, tend to speak more. Which makes sense, right? Smaller group, more pressure to talk. The agent did that too.
Okay, that's genuinely impressive on the timing front. It sounds like it nailed the rhythm of the conversation. But rhythm isn't everything. What about the content? Did the messages sound human?
Now that's where things get really interesting. While the timing was close, the content not so much. There were some clear differences.
Like what?
Well, for starters, the LLM agent tends to send longer messages, significantly longer.
How much longer?
Humans average just over 4 words per message. The LLM, almost 11 words per message, so more than double.
Okay, that's quite a difference. Anything else?
It also showed slightly higher repetition in its phrasing and actually used a larger vocabulary size overall.
So longer, sometimes repetitive, but using more words.
Kind of, yeah. And these differences were stark enough that they could be identified computationally. Using something called message embeddings, like unique digital fingerprints for messages, and a machine learning technique, they found that human and LLM messages were easily separated into distinct classes.
How easily?
They achieved an F1 score of 0.98 for distinguishing between LLM and human messages. That's incredibly high. It basically means that despite the human-like timing, the way the AI wrote was still very much identifiable as non-human, at least to an algorithm.
So a different linguistic style, even if the beat was right. Interesting. Did they check if other things were distinguishable, like player roles?
They did. And yes, player roles, Mafia versus bystander, and even different game phases, like discussion versus voting, could also be distinguished based on the message content. Language really does shift depending on the context.
Okay, so timing, good. Content, different.
Yeah.
How did this mix translate into actual game performance? Did the AI win often? Did its longer messages make it suspicious?
That's the crucial question. And despite the content differences, its performance was surprisingly strong. The paper reports its win rate is similar to the performance of human players, both as a bystander and Mafia.
Really? Even with the longer messages?
Yep, which is a pretty strong sign that it integrated successfully. Because as you said, in Mafia, bad communication usually gets you voted out fast.
Did they confirm that being too talkative is actually bad in Mafia?
They did look at that correlation. And yes, being too talkative correlates with being voted out. The players who sent the most messages were significantly more likely to be voted out. So the agent's design, with that dynamic scheduler aiming for balance, seems validated. Avoiding extremes was key.
Okay, that makes sense. Now, what about the humans? Could they tell who the AI was? You said the algorithms could spot the difference easily?
Right, but the humans, not so much. When asked to identify the AI after the game, only 59.6% answered correctly.
So, barely better than chance.
Pretty much. Which strongly suggests that the human-like timing really helped it blend in, maybe masking some of the content differences from human perception during the fast pace of the game.
And the ratings humans gave the AI afterwards.
Consistent with that, timing got the highest rating, 3.19 out of 5. Then came relevance at 2.99, and human similarity was lowest at 2.63.
So humans thought its timing was okay, relevance was decent, but they weren't fully convinced it was human-like overall. Mostly because of the content, presumably.
That seems like a fair interpretation, yeah. The timing really carried it in terms of blending in.
This is fascinating work, but like all research, it must have limitations, right? Areas where maybe future work could improve or explore further.
Absolutely, and the researchers are quite upfront about them. It raises that important question. What were the constraints here?
Okay, like what?
Well, one clear factor is the size of the LLM they used. Llama 3.18b Instruct is capable, but it's still considered a relatively small LLM by today's standards.
Right, there are much bigger models out there now.
Exactly, and it's possible that larger, perhaps more sophisticated models might behave differently. They might generate more human-like content or maybe even exhibit different timing patterns. That's an open question.
Makes sense. What else?
Another point they mention is the participant pool. While all participants were fluent in English, it did include non-native speakers.
How might that affect things?
Well, they suggest this linguistic diversity may have influenced our ability to distinguish between human and LLM-generated messages. Subtle differences in how non-native speakers use language might sometimes resemble LLM patterns, or vice versa. This could partly explain why the message embeddings were so separable the human baseline wasn't perfectly uniform.
Ah, okay. So the AI might have stood out more partly because the human group itself wasn't linguistically homogeneous.
It's a possibility they acknowledge, yeah. Something to consider in future studies.
So, acknowledging those limitations, where does this research point next? What are the exciting future directions?
They lay out quite a few interesting paths. One area is exploring alternative asynchrony strategies.
Different ways for the AI to decide when to talk.
Exactly. For example, what if the generator creates a potential message first, and then the scheduler decides whether to actually send it? That might mimic how humans often formulate a thought before deciding to speak.
Oh, interesting. Like thinking before speaking.
Kind of. Another idea is fine-tuning the LLM to output a specific, like, pass token when it decides not to say anything, a more explicit way to model silence.
Instead of just not generating anything.
Right. And they also want to compare the scheduler-generator approach with simpler, maybe turn-based inspired ideas, like having the LLM just speak every, say, 5 new messages, just to see how the different strategies stack up.
Okay, so exploring different AI architectures, what about the data and environments?
Definitely. They want to do broader data collection. They mentioned potentially using platforms like Textarena, which hosts various language-based games and interactions.
So testing it beyond just Mafia.
Yeah, getting more diverse human LLM interaction data. This could allow for deeper research into really complex group dynamics and open-ended behaviors, seeing how these agents handle different social situations.
And presumably addressing the limitations we just talked about.
For sure. Using larger LLMs, recruiting perhaps more linguistically homogeneous groups for some controlled experiments, or maybe specifically studying interactions within diverse groups, all that would help refine the findings.
It sounds like there's a lot more to explore here.
There really is. But ultimately, what this deep dive shows us, I think, is a genuinely novel and effective approach for LLM agents to actually participate in asynchronous multi-party communication. That's the big takeaway.
Yeah, they really proved it's possible. They showed an AI can make sophisticated decisions about both what to say and, maybe more importantly, when to say it. And it worked pretty well. It achieved competitive game performance, blended in surprisingly well with humans, especially on timing, even if the message content was still a bit distinct.
Exactly.
And the implications feel quite broad, don't they? This work really highlights that adding this asynchronous capability to LLMs is feasible and potentially really valuable. It sort of paves the way for LLMs to integrate more naturally into real-world collaboration.
You can imagine it in online meetings, maybe helping facilitate, or in classroom discussions, or even online support groups, places where knowing when to chime in is just as important as what you contribute.
Absolutely. Makes AI feel less like a tool you query and more like a participant you interact with.
Which brings us to a final thought, perhaps. As these LLMs get better and better at reading the room, at navigating these subtle social cues like timing, how does that change things for us?
You mean, if an AI can truly blend into a conversation, timing and all, does that change how we perceive interaction itself? Especially if we don't always know who is human and who isn't.
Exactly. What new ethical considerations pop up? When an AI can mimic not just language, but the very rhythm of human conversation, what does that mean for trust, authenticity, and our relationships with technology, and maybe even each other?
That's definitely something to mull over. As AI steps further into our social spaces, how will its growing understanding of conversational timing reshape our own interactions? Lots to think about there.